Today, we're going to extract crystals of caffeine from coffee. But to do that, we have to first brew the coffee, the chemistry way. Let's go to the lab. The process of brewing coffee is what chemists refer to as a solid liquid extraction. The apparatus we use to perform this is what's known as a socklet extractor. Here's how it works. We filled this chamber up with ground coffee beans, and this flask below we filled with water, which was then heated up to boiling. As the vapors travel up this sidearm, it will meet a piece of glassware which will condense them and cause the liquid to collect here in this chamber. When this chamber is almost completely full, a siphon begins because of this small sidearm, and all of the solvent is drained back into the flask, so that way the cycle can be repeated. So we can take our coffee, and now we're ready to extract the caffeine out of it. To extract the caffeine out of our coffee, we performed something known as a liquid-liquid extraction. We used a solvent known as dichloromethane, and we put it in something known as a separatory funnel. Caffeine is much more soluble in dichloromethane than it is in water. So the caffeine will leave the water and join the dichloromethane layer, which can be very easily extracted with the separatory funnel by turning this stopcock. And that will collect the caffeine and dichloromethane for evaporation. To purify our caffeine, we used a technique known as sublimation. So we took our caffeine from the solid state to the gas state and then condensed it back into a solid onto a test tube, and that produced very pure caffeine. And here are the extracted crystals of caffeine from our coffee. If you're interested, we used Vietnamese Robusta coffee beans for this experiment. That's because of their very high caffeine content. So this has been Chemistry in Context at Harless & Hugh Coffee. Stay safe.